Hey everyone, welcome to the lab. I'm your faculty instructor, and today we're stepping into our modern psychology laboratory for a really fascinating practical. We've got our professional volunteers seated right here, ready to go, as we explore the exact mechanisms of human memory. Today's explainer is all about Experiment 4, where we study the position effect in serial learning.
Let's dive right into this by watching our volunteer try to memorize a sequence of items. Have you ever noticed that when you hear a super long list, the first few things and the last few things stick out perfectly in your mind, but the middle is just a total blur? It's kind of a fundamental mystery of how our memory works, and we are going to methodically unpack it today. Here's our game plan for today's explainer. 1. Intro to serial learning. 2. Materials and lab setup. 3. Conducting the memory experiment. 4. Distraction and free recall. 5. Plotting the data curve. And finally, 6. Discussion and final conclusion.
Let's kick things off with Section 1, Intro to Serial Learning. So, what exactly is serial learning? Basically, it's a learning situation where the learner gets material in a very specific, sequential order. You're learning a list of items according to the strict order in which they appear. This whole concept works on the principle that an item's position strongly influences whether it actually gets memorized. And that holds true whether we're talking about meaningful words or just random nonsense syllables.
The really crucial takeaway here is that recall accuracy varies depending on where an item sits within a study list. We call this the serial position effect. Memory is generally much better for items placed at the very beginning, which we know as the primacy effect, or at the very end of a list, the recency effect. Because of this, recall is usually a lot lower for those middle positions, while the primacy and recency effects completely dominate the sequence.
Moving right along to Section 2, Materials and Lab Setup.
Our official aim for today's practical is pretty straightforward, to study the position effect in serial learning. And along with that aim, we have our assumed alternate hypothesis, which is that there is a positive effect on serial learning.
Now, when it comes to our methodology, precision is absolutely everything. If you look at the desk in front of our seated participant, you'll see the exact tools we need all laid out. We've got a set of 15 trigrams printed on cards, a stopwatch to make sure our timing is flawless, a wooden screen to manage exposure, and writing materials for the final recall phase. This professional setup guarantees there are zero external variables messing with her focus.
All right, Section 3, Conducting the Memory Experiment.
To ensure total uniformity, we conduct the experiment in a single series. A list of 15 trigrams will be presented to our volunteer in strict serial order. We're going to do exactly 3 trials, and between each of those trials, we have to provide a rest pause of exactly 10 seconds. That 10-second pause is a specific precaution to prevent the effect of interference.
I literally cannot overstate the scientific rigor of these timings. That stopwatch on the desk, it is definitely not just for show. Each card has to be exposed for exactly 2 seconds. After each trial, we initiate that 10-second rest pause. Then, after the third and final trial, a 1-minute distraction period kicks in, which leads directly into a 2-minute free recall window. These are our intervening variables, and controlling them precisely is what makes this a valid experiment.
So our volunteer is seated comfortably, rapport has been established, and as the instructor, I give her this exact instruction. I will show you a set of cards which contains trigrams. Look at it carefully and try to keep them in mind. Notice how carefully that's phrased. It is absolutely crucial that the subject isn't aware she's supposed to recall the items in order.
I give the ready signal and the exposure begins. One by one, our 15 uniformly difficult trigram cards are revealed, for exactly 2 seconds each in serial order. Watch as they appear. Woon, Rahl, Bach, Mux, Cool, Dih, Mott, Gib, Sig, Lef, Cag, Jack, Ned, Yed, and finally Quat. We repeat this precise sequence across all 3 trials. Which brings us to Section 4, Distraction and Free Recall.
Immediately following that third trial, we drop in a 1-minute distraction period. Why? Rehearsal. Active practice improves retention, right? So to avoid rehearsal, this distraction period is given. It's a vital control variable that stops our volunteer from actively practicing the sequence in her head, ensuring that her later recall relies purely on the established serial position effect.
Okay, Section 5, Plotting the Data Curve.
After that 1-minute distraction, our subject gets exactly 2 minutes to freely recall the trigrams however she wants, using the writing materials we provided. Once she's done, it's time to record the dependent variable and analyze the data. We do this using Table 1. On this chart, we meticulously record the number of correctly recalled trigrams against their exact serial positions, numbered 1 through 15. The independent variable is the serial order of presentation, and the dependent variable mapped here is the number of trigrams recalled correctly.
Now, this is where it gets really interesting. Notice how these 3 bars visually map out the expected psychological phenomena. When we graph the serial position on the x-axis against the number of trigrams recalled on the y-axis, we typically see a prominent peak at the beginning representing the primacy effect, a distinct dip right in the middle positions, and another spike at the end demonstrating the recency effect.
Finally, Section 6, Discussion and Final Conclusion.
Now we have to evaluate the raw data mapped in Table 1 to see if our volunteer actually demonstrated those expected psychological behaviors laid out in our aim. This brilliantly illustrates how we interpret our subject's results against the alternate hypothesis. We examine her genuine recall outcome to see if she exhibited both the primacy and recency effects, alongside that expected lower recall in the middle positions. We take these observed results and directly compare them with the assumed positive effect on serial learning.
And that leads us to our formal conclusion. We never invent a result here. The conclusion depends entirely on the participant's actual recall pattern. We formally state whether the genuine results recorded in Table 1 support or disprove the alternate hypothesis that there is a positive effect on serial learning.
So, let's take a step back and look at what we've accomplished in the lab today. We started with a clear aim, systematically exposed our volunteer to 15 trigrams across 3 rigorous trials, implemented a distraction period to prevent rehearsal, and finally, mapped her recall into a serial position curve showing primacy and recency. It's just a beautifully structured glimpse into how our minds prioritize sequential information. I'll leave you with this thought. Knowing that you are literally biologically wired to forget the middle of a sequence, how does this shape your own daily memory, and how might it change the way you study or work tomorrow?